Um, Hi everybody, it's nice to be here and talk with you today. I've been closely associated with the University of Wisconsin for 15 years now, and I saw Alan present all the IMAP and CSVP conferences and workshops held during the course of all the years, and this is how I met the CSVP team in 2006 when they presented a course in South Africa. That's where I'm from. So thanks to the CSVP team, I'm here. I'm still here. So, I will talk today about how we leveraged CSVP tools and services to meet forecaster needs, both scientifically and in weather forecasting. And I'm not even today speaking about the work my colleague Chris Barnett is doing, but I would like to thank Alan for mentioning that earlier. We and Chris Barnett and myself, we're at STC, and we have a very strong partnership with both NASA Sport and SSAC Wisconsin. And Chris is currently working with Agnes Lin and Alan and Zhenglong to develop a NUCAPS capability for the FY instruments, and that will probably be presented at a later conference. So today also the work is testimony to partnerships. That is the key word today. So what we have done, what I can say without reservation, that the value of infrared, hyperspectral infrared observations in weather forecasting today is that NUCAPS satellite soundings, NUCAPS is the NOAA operational system algorithm for hyperspectral and microwave instruments, for polar orbiting LEO instruments. It has been operational at NOAA for many years and for many, many different instruments. So with those satellite soundings, the retrieved soundings, the forecasters are able to answer these questions. What happened? They can do analysis and case studies, and they can also answer the question, what is happening right now? It's a nowcasting tool. And then the CRIS radiances go into forecast models to help forecasters address what will happen. So this is what NUCAPS looks like in AWIPS as QT diagrams. You can click on any one of these dots and a QT diagram will pop up. I know nothing about QT diagrams. I'm an algorithm and product developer, but the forecasters know how to extract a lot of information from those diagrams. We also use this color coding as a QC, a quick visual QC tool. So they find it really valuable to be able to click on a red dot and see what a failed sounding looks like, to know how a sounding fails when there's uniform clouds and what it looks like when it succeeds. And this is what typically comes up. So all that we do is feed through the files to AWIPS, and in AWIPS, which is the US tool that forecasters use to do visual analysis, it's all these extra things that the software calculates from basic moisture and temperature profiles. So we only feed through the basic retrievals. But just as recent as 2016, there was no way for forecasters to address the question, what is happening now? They couldn't use soundings in nowcasting, and it's as recent as 2016. And sometimes I have to pinch myself to appreciate how far we've come. Because at that time, there was NUCAPS available from SUMI NPP. And the latency of that product was 2 to 3 hours. It didn't make it into AWIPS when it was already too late. It was already not good enough for nowcasting. And so we were funded by Mitch and the JPSS program at that time to figure out a way to better service forecasters with soundings and to see whether there's even a future for soundings in the weather system. Do forecasters care about retrieved soundings? And so today I will talk about these tools and services that we have used and how instrumental they were to help us address these forecaster needs. So I'm a user and a contributor to CSVP. I used to be a contributor, now I'm a user of it, but as a product and algorithm developer. So the first one came from Alaska. It was Christine Nelson from one of the weather forecasting sites there. And she reached out and said, well, they do this. They send out these meteorological impact statements to air traffic controllers because the air traffic controllers, because of the high volume of planes and air traffic over there, they want to know where these really cold air features are. These are three-dimensional blobs of really cold airs, minus 65 degrees Celsius. And the models they don't have many radio sounds or a strong network of radio sounds there, and the models sometimes disagree, and then they do not know where this cold air is. And for the planes, or for the pilots, they would rather avoid those blobs of cold air for fuel efficiency and also air safety. So how they forecast this is they want to show the lat-long extent, the spatial extent of it, as well as the depth of it. So they really would like to tell forecasters what is the three-dimensional extent of this blob. And given our visualization in AWebs, where you can interrogate basically one sounding at a time, you click on this sounding and pop the obscurity diagram appears. It means they can't really do that efficiently, because then they have to click on hundreds of them to see where it is. And so we had to figure out a way what to do. So what we did was we used the CSVP Polar to Grid software and asked Dave Hayes, the developer, to help us change that so that we can read CSPP, NUCAPS level 2 files. And then that put the satellite soundings here that is still on the instrument grid. It could then be used to create basically a quick level 3 product. So it grids it spatially and vertically in the pressure level. So we make basically a data cube out of it. And then NASA Sport then obtains this direct broadcast data, runs the CSPP tool locally, converts that to GRIP2 format, and then send it over local network to the AWeb's office. And because of this, we were able to then demonstrate that if you can visualize the product differently, not just as individual profiles, but differently as layered surfaces that go up and down in the atmosphere, you really increase the information accessibility of these products to the forecasters. And we used CSPP to bypass the NOAA SPN pipeline to then develop custom products and significantly increase latency. And this partnership that we developed also then with the forecasters in Alaska was so successful that one of the forecasters actually led a scientific publication on this whole process. So we all learned quite a bit from it. And so here is what you can look like now in AWebs. You can have a volume browser where you dissect that data cube along the vertical, and you can clearly see that now that vertical extent of that cold air blob, and then also horizontally. And you can move this horizontal view at different pressure layers. So you can almost go up and down in the atmosphere like that. And you can see it's exactly the same data as the QT plots. It's just visualized differently, and that gives a very fast information delivery to the forecasters. And then as a byproduct of this system that we set up using CSPP tools and direct broadcast services was that we had now very low latency NUCAPS soundings in AWebs. And so we could explore what do soundings mean in severe weather forecasting. And here we talk specifically in the continental US in the early afternoon orbit, when and how can forecasters use these soundings. And here is this. We worked with them very extensively to determine at which point in a weather forecasting process can these soundings be valuable. And it's really to assess that preconvective environment. I would like to thank Brandon from GALM yesterday. He really gave a good shout out to NUCAPS, and Scott Lindstrom has been working with him also. We really, it takes a whole team to support this effort and to really help the product developers improve the product, and also the user base to get them in on the fold and give them really that sense of ownership of the product, so that they can then go and do their own creative uses of it, you know. So once we determined, my goodness, NUCAPS can actually have value in weather forecasting, there was so much new that came out of that. And this was still using the direct broadcast data stream, because remember, NUCAPS from SUMI NPP was way too slow. The forecasters need that sounding within an hour of satellite overpass. And to the direct broadcast CSPP team, that sounds really slow, because really what we do is that soundings become available within minutes. That the overpass happens, you process the data. NUCAPS is very fast and robust. It's within minutes that you have the whole swath processed. And that gives enough time for downstream applications to then happen. You can then grid it, you can do something else with it, and it's still well within the latency of the forecaster requirement. Here is an example of a cross-section of NUCAPS that the forecasters recently did, showing the dew point is the image in the background, and the lapse rate is then as contours over this dew point. And this is all derived from the temperature and moisture fields. Here's another example. The forecasters can use the gridded product as is. We basically just bind these soundings to a regular grid. We do not interpolate it. We want to preserve the original values, but they can also smooth it out and interpolate it in as a visual product. So they are now able to use gridded NUCAPS fields to verify the SPC meso analysis. So the second example I want to give that we were able to leverage CSPP tools and services is recently funded by NASA and JPL, because as you all know, the NUCAPS, no, the Aqua platform with AIRS and AMSU will be decommissioned in 2023, and AIRS and AIRS soundings have never been in AWIPS for weather forecasting. We wanted so much to address the forecaster need that they said they need a higher frequency of soundings to help them assess the development of a storm. And the first year we were gearing everything up to have NUCAPS from NOAA 20 and NUCAPS from SUMI NPP, but then COVID happened and it wasn't an evaluation that year. The next year, the CRIS instrument on SUMI NPP, one of its bands failed, and just before the start of HWT. This year, we were able to get, for the first time, two satellite overpasses from different platforms in the early afternoon orbit, so that we can assess whether, if these satellite soundings are sensitive enough to pick up on small changes in instability in the atmosphere to help with situational awareness. So what we did was, here in the blue part here, this is the heap distribution of NUCAPS from NOAA 20. NOAA distributes NUCAPS under the heap, so yeah. Sometimes there's a confusion there, but this is the CSPP distribution using oh no, that can't be. No, this can't be. It can't be heap. It has to be. It's not CSPP heap. This is the NOAA operational pathway that is established. We used the science code. This is our STC science code of NUCAPS adopted for Aqua that we then used to. We used level 1B products from the IMAP software. That's still running, it's still being received, it's still here. We use those products from AIRS and AMSU with a direct data broadcast stream, and Jim Davies was really instrumental in helping us set that up. And we also used our offline NUCAP science code to run this in real time, put it on an FTP side, have Sport grab it, and then process it to ingest into AWIPS 2. So for the first time, we had a tandem of satellite soundings in the early afternoon orbit. And our HWT evaluation finished just last week. It ran for 3 weeks over a 4-week course. So here's just a demonstration of this partnership and how when you use these tools and services and partner with the right people, then you can really make big things happen. Here's our AIRS AMSU level 1B data. I have color-coded it here to show how all three partners have worked together. SSAC is here in my favorite orange color. STC is here in blue. This is what we have done. And then Sport takes and does the processing, post-processing. So we did our algorithm development and all of that, and then it was run in real time and sent to AWIPS so that it would arrive at the same latency that NUCAPS from NOAA 20 arrives. So, 5 minutes, okay. So here's just some examples and blog posts. There are a lot of examples here, and anybody who's interested in this, please email me. I have my email up on the final slide. We would like to send you resources. In the process of us working with forecasters, we've developed quick guides, we've developed science application guides, we have developed a way to figure out how to keep a dialogue going with forecasters to better understand what they need, or how we can better improve it. We have solid partnerships in place to make this work fast and well. because this work from NUCAPS Aqua could be funded and be implemented based on the pathways we already established with our JPSS funding. So these are just now feedback from a forecaster. This is one sounding from NUCAPS NOAA 20 at 1823 UTC, and just at 1990 UTC there was another NUCAPS Aqua overpass. They could compare that skewed T diagram and indeed see that the environment grew more unstable. Here is another example of the two overpasses, NUCAPS from NOAA 20, again a bit later, NUCAPS Aqua, and they could clearly see instability here. And this instability was confirmed by the weather happening that day, and none of the models saw that instability and that increase. So we have clear evidence here that from different platforms, and you apply the same algorithm, you can really see those changes. There was also a few days where they launched special radio sondes, and the National Weather Service can at times request special radio sonde launches outside of the standard timeframes to help them assess difficult weather situations. And here, the purple line in the back is the radio sonde, and the NUCAPS Aqua sounding in green over the top of it, and they show exactly the same type of environment. So that is all very, very encouraging. So in summary, we can leverage CSVP tools and direct broadcast capability to meet emerging needs for satellite sounding products. All of these changes, the work we did to develop the data cube, first with CSVP tools and streaming via direct broadcast, we have since developed that as a Python plugin for AWIPS to be part of the official AWIPS distribution. So we were able to first do a demonstration and a prototype of it before it became operational, so it becomes very cost effective. We also now, based on our recent HWT, we can prepare our sounding products and services as well as our user base for NUCAPS from JPSS2, where there will be 2 satellites in the early afternoon orbit. Currently, AWIPS struggle a lot with the same product from 2 different satellites, and we have to figure out a way to overcome that. But we're also able to move beyond AWIPS too, to build web-based visualizations. There's the Sport Viewer, there's standalone tools where we can ingest NUCAPS into SharpEye, AWS tools where we actually starting to explore how to build tools for sounding products in the Amazon cloud, and also develop new applications for NUCAPS trace gas retrievals. Our director at SSSC is doing a data assimilation with NUCAPS trace gas products, but the operational product doesn't have averaging kernels in it yet. So what we can do is use our science code base to implement those averaging kernels, have that data stream set up, and so that he can grab the data and assimilate it to the data products, and develop and demonstrate this capability in lieu of that capability becoming available in the operational product. And we also have a little bit of an exciting product to use ozone as an indicator of storm intensity, and that's with Carl Dierking from GINA. So we'll be talking some more and probably write a little proposal for it or something. But anyway, thank you very much for today. And if you have any questions, please contact me or my very close colleague, Emily Barron. So thank you.
Thank you, Nadia. Do we have any questions for Nadia? Yes, I see one. Satya.
Nice presentation. 2 questions. You said the users are struggling with data from satellites.
The AWIPS platform is struggling with NUCAPS from 2 platforms. It doesn't know, like with the gridded NUCAPS in there, it mixes it together. It's the way AWIPS was set up to deal with soundings either as a radio sound, one sounding at a time, or with a regularly sized grid as a model field. It was never planned to be using satellite soundings from NUCAPS. So we keep coming up against these little glitches in AWIPS. Yeah.
Okay, so is that a science question or a software question or a capacity question?
All three of them.
All three.
Not a science one, we've got
Maybe
the science
should
one.
provide them with both. The second question is, maybe Nadia can provide an answer. NUCAPS is in CSPP, right? Do we know how users outside our weather service internationally are using it? I have not seen any literature or anything about NUCAPS use. Do they know how to use it?
So I have a talk that, the last talk of this whole meeting is the hidden users of CSPP, because, we have this huge user community, but we're not sure what products they're using necessarily and how they're using them. So right now, I'm trying to think of any users that I know of outside of the weather service that are using NUCAPS right now, but I bet there are some. I just don't know who they are.
Yeah, I mean, we know pretty well how the radiances are used by the simulation community. I think fairly well how Pierce is used for imagery, fires, floods, and things like that. But these specific handcrafted products, I'd like to know more about how the international community uses.
Well, I mean, probably Nadia covered this, but certainly Gina is running NUCAPS and SSCC is running NUCAPS.
Guam and also Hawaii. So.
Oh, in fact, I was going to ask you, which DB sites are you actually getting DB data from?
All of them. And
Can you name a few?
The ones that SSCC supports, the products
so,
that you have.
You get the Fairbanks data, the Alaska data from Fairbanks. But you also get data from Guam, Hawaii, Miami, Mayaguez, Puerto Rico, Madison, Hampton, Monterey. Okay. Anywhere else?
We basically, Corvallis.
Not Corvallis. Used to, but they've been offline for a while. Sorry.
Yeah, it's a robust software. We can access any of those and run it, and it's being set up to even the experimental products that Sport can even run it and then push it over the LDM to AWIP's offices wherever, but based on DB data from the DB cast or the new network cast, So yeah, it's easy.
Going back to users of NUCAPS, I think the problem is, and you pointed out in your last slide, that it's not an application tool for displaying NUCAPS beyond AWIPs, right? So it's not like imagery. Imagery, you show an image, you see things, everyone will use imagery. So we have to develop that visualization tool with the training, and then people start using it quite a bit. So my original question was, what am I going to ask? Do you know what I'm going to ask?
Should we cancel NUCAPS?
No. What about Sumi and PP? Why didn't you include Sumi and PP? You have no 20 through layers.
It's not currently.
But it's through CSP. It's the same.
No midwave channels.
No, there's no midwave. The midwave band of the CRIS instrument failed, so we can't do our water vapor retrievals.
But you say I and just make it up. Never mind. I forgot about that Sumi and PP.
Yeah. Otherwise, we would have had 3 instruments in space. Yeah. Yeah, thank you. And it wasn't until we developed this basically a real-time level 3 product, if you may, a gridded product, that we opened up all these other applications. It just shows you the power of visualization for science and forecasting. Oh yeah. And for fast delivery of information,
To provide answers to Sasha, according to the registration map, NUCAPS was registered from Russia, Federation, Republic of Korea, Indonesia, United Kingdom, France, Taiwan, Canada, India, Italy, Australia, Laos, Germany, Spain, Argentina, Egypt, Japan.
Can you slow down? Can you slow down?
Using it, what's her name? DWP.
So I got a list of different countries. Singapore, Hungary, Malaysia, Mexico.
But one of the more satisfying things about this even is that initially we QC'd, quality controlled the gridded product and made little gaps or big gaps wherever there are clouds. The soundings fell over uniform cloud fields. And then the forecaster said they would rather not see the gaps, they'd rather see where it fails. So don't QC it. So now we have smooth services. Even where it fails, and even in our documentation, our quick guides, our interaction with the users, and seeing them independently of us writing their blog posts, like, oh yeah, so I can see this feature here is now due to over the cloud field, so that's for bad sounding, but I'm looking past it in this area here, I can see this and this, and it's just like, wow, there's efficient communication happening here, so that's really satisfying.